Thank you all for coming. I'm pretty excited to be here. The first NDC edition in Minnesota, so I'm very excited to be here. I hope you are as well, and enjoying these conference. Well, actually, I prepared this whole nice introduction for this session, and then this morning I was at the keynote, and am I understandable like this? Yeah. Okay. So. And there was this big talk about, well, how all the stuff works, the radio waves, that kind of stuff. And basically, a lot of this talk is going to be about that. Well, not about the actual radio waves and that kind of stuff. I'm way not smart enough for that. But yeah, it's going to be about networking and that kind of things. So when I'm talking about an app, it's not just the thing that's on your device. I'm also talking about the backend. You probably have some backend system running in the cloud, on Azure, whatever. And there's a whole world between that. That's also what the keynote was about, right? There's this whole world between it, going through all these different nodes, and it's transporting your data from half a world away to your mobile device. And that's a big part of our apps, but it's not always that reliable. I mean, people are going everywhere. I came here by a plane, which is going pretty fast, and still we have Wi-Fi these days on those planes. We're going through tunnels where our signal can get lost all of a sudden. Hell, we're even sending Teslas out into space. So I don't know how the 4G is in there, but yeah, it would be nice to receive my cat pictures there. And as developers, we're expected to take this into account, to foresee all these scenarios, and to be able to, yeah, still deliver a good user experience. So who am I? My name is Gerald Versluis. As you might have expected, I'm not from around here. I flew in from the Netherlands. So yeah, it's my first actual overseas conference. So a bit nervous here. Give me a break. There are some contact options. Wow, I look a bit stretched, I see. Well, and basically my Twitter handle, you can find me everywhere. It's also for GitHub and that kind of stuff. So yeah, just Google me and you'll find me. I blog a lot about mostly Xamarin stuff. I focus on Xamarin mostly, but also, as I mentioned, the ASP.NET, REST APIs, Azure, that kind of stuff. And if there's anything more, just reach out to me on email. I work at a company called called Dot Control. And well, as I just also mentioned, there we don't try to, don't worry, I'm not going to give you a full sales pitch. We don't just try to deliver value to our customers, as anyone wants to do, but we try to deliver, well, digital ambitions, as we like to call it. And as a part of that, yeah, there's also these things like your app taking into account that the networking might fail. So yeah, that also works for your user experience. And this is basically the thing. It doesn't even matter if your app feels fast or works great. It's just that the user has to think that it does. And that is basically what you will learn in this talk, hopefully. Because yeah, users have high demands, as they should, because there's a lot of great apps out there who do this perfectly. So yeah, why not ours? If your app doesn't do this right, then it will get deinstalled, and it's pretty hard to come back from that. And maybe even worse, you will get 1-star reviews, and yeah, then other people are not even going to try your app. So that's something that you want to be in front of. And a lot of what I will show you today is helping to make the user think that your app is better than it actually is. So let's take a step back and look at the challenges that you have as a mobile developer. Who is actually a mobile developer with Xamarin? Okay, cool. Because all of the most of the stuff that I'll be showing you today, well, is going to be in Xamarin, .NET, that kind of stuff. But I think, of course, you can't use the actual libraries that I'll be showing you. But a lot of the concepts can be translated to other platforms as well, maybe even desktop and that kind of stuff. But the stuff that I will be showing you is with Xamarin. So if you go back to the challenges that we have, most of the people are mobile developers, so you'll probably know this. First off, if we start from top to bottom, there's a lot of APIs that you have to know. So especially if you're working with Xamarin, there's thousands of iOS APIs, there's thousands of Android APIs, and then there's the .NET Framework APIs also. So yeah, that's something you have to get all sorted out. And learn how to work with all of those. Then you have the public APIs. Well, maybe it's not. Yeah, it's going to be a public API because you have to reach it from your device. But if you're lucky, then the backend is also written by you. So if something weird is going on there, then you can fix it yourself. But maybe you're using someone else's system. So then you just have to deal with whatever it's throwing at your app, and you have to deal with that. Behind that, there's the back-end integrations. I'm actually working on a project right now, and we have this public web API in front of it, but the back-end integrations, they themselves are actually calling it the jungle, so I probably don't even want to know what's going on in there. But yeah, that can be a complex system as well. There's a lot of systems exchanging data. There's a lot of stuff going on that you don't even want to know about, but yeah, it's going to be also digging into some user experience if weird things are going wrong in there. Then there's the third-party libraries. I think this is also mentioned in the keynote, so he made a nice preparation for my talk. There's a lot of good libraries out there, but still you are making yourself rely on those libraries. So you should always inform yourself, like, hey, do I trust this person or this company that's behind it? Most of them are out on GitHub, so that's good. You can inspect the code yourself or maybe change something in it. But yeah, if you go search for a library and it hasn't been maintained in like 2 years, there can be a good reason for that. But then you should probably think to yourself, hey, do I want to use this or not? And if something misbehaves in that, I think at Build right now, they've announced some really nice system. Was it SourceLink? Is that the thing? I'm not sure. But there's going to be a service where you can upload the debug symbols, and then you can easily debug through NuGet sessions, NuGet packages from third-party libraries. So that at least makes it easier to see if the bug is in there or maybe in your code. Because I always think like, hey, those are smart people publishing those libraries, so it's probably me. And it turns out it's not always the case. So the last thing, memory, CPU, and networking. That's probably what this will be mostly about. Because the device that we have right now are still more powerful than the first PC I ever had, but yet the limitations for CPU and memory are still there. If you're used to desktop development, you can go far before you reach depending on the machine you're using, of course, but you can go do a lot of stupid things before you reach the maximum of that. And for mobile devices, that's still very limited. So also, if you start using the CPU a lot, the battery starts to drain and users will find out quickly. And again, they will just deinstall and that will be the end of it. And for the networking constraints, well, the mobile connection is not always stable. I think we all know that. I don't know, even in the tiny country where I'm from, there are some places where you don't have a good cellular connection, so I can't even imagine how it will be in a big country as the US. And also bandwidth costs money. I think the example, again, from the keynote, so thank you, was, I don't know, a cat picture cost like a lot of beers. So yeah, we don't want to do that. I mean, we will probably have pretty good cellular, what do we call it? packages for your phone. But there are countries where maybe that's not the case, where bandwidth, and actually in the Netherlands, bandwidth, while we are working on going to unlimited plans, we're not there yet. So it's pretty expensive, relatively, to get some data for your mobile phone. And network calls take time. So, yeah, whenever you need to go to a backend and back, yeah, that's just going to cost time, and you want your user to have some kind of sense of that things are going on, and they are not waiting and starting to reload, and getting in more bandwidth, more data, and getting themselves into trouble. So, in the 90s, there were two smart guys at Sun Microsystems who made these assertions, which they call the 8 fallacies of distributed computing. And actually, till today, they are still very accurate. And especially on mobile, there's, if you look at them, they're not all applicable, but, well, the network is reliable is the number one thing. Yeah, and we all know that is not always the case. So, if we want to do something about this, then we need some tools to simulate things. Because, well, you can go to somewhere far in the desert to get a bad cell reception, but probably that's not something that you want to do for every bug that you are trying to squash. And actually, I was quite surprised. You would thought in terms of the networking and memory and CPU constraints on your device, you would expect that the simulator and emulators you're using while developing are also simulating these constraints. That's not really the case, especially on iOS. The iOS simulator just uses all the RAM and all the disk space that your development machine has. So yeah, it all works great there. But if you start working on a real device, then yeah, all of a sudden it might not work that great. And that's also the case for the networking, of course. You're probably going to have a great Wi-Fi connection at your office, or maybe even plug in the cable, so everything's fine there. But you still want to have then some tooling around, being able to simulate these bad network conditions. So there are some options for that. For iOS, there's the Network Link Conditioner. It's an additional download from the Xcode from the Apple Developer Portal. You have to search for it. It's a bit, I think it's also referencing like Xcode, some old version. But whenever you install it, then you will have an extra, just let me show you, extra networking pane. I have to switch this here. Then the resolution goes bad. That's not great. Sorry for the switching around. Let's try to keep that to a minimum. All right. And then you get this new option here, the Network Link Conditioner. And there we can switch it on and off and define different profiles to simulate different network connections or different network conditions. There's a few presets already in there, but you can also manage profiles and then configure a bunch of stuff to simulate some pretty specific conditions right here. To not keep going back and forth, I will just show you the rest here. In the stock Android emulator, which is not ideal, but you have some options here built in. Here at the options of this simulator, you can just go in and you have a pane cellular where you can choose a network type. The options are somewhat limited, more limited than the iOS ones, but yeah, you can still simulate some stuff here. Like the signal strength, but you don't have full control over the exact numbers that's behind this. I like to use the Genie Motion emulator, and it also has some options for this, but it only is for the paid version. You can also do this, the network link conditioner for your physical device. Then you just hook it up to Xcode once and mark it as a developer device, and then in your settings app, then you get the network link conditioner as well, just as on macOS. And well, it basically works the same. You have the different profiles and you can create one yourself, etc. So in the Android emulator, I already showed you. Then, if we have that set up, then of course you want to see what is going on. I mean, networking can be a black box. You don't know what's going over the line. Are requests going one way? How big are they? And if you have these network conditions, a certain profile, then can we see what that does to our connection and our app? So that's the other way. We want to measure and get some insights on what is going on. What goes over the network. The first thing is Charles. I think the next one is going to be Fiddler. That's probably more famous than the Charles one, but they'll more or less do the same. You just get a list of every request that comes from your development machine and it comes back to it, and you can click into it and see what is going on there. Of course, nowadays, hopefully, most of it is HTTPS, and you have some troubles there because you will have to install a fake HTTPS certificate to be able to inspect the actual contents of your request. So that can be a bit of a hassle to do. It can all be done also on your physical device, also on your simulator, but yeah, it is a bit of a trouble to go through. Charles is available for Windows, Mac, and Linux. It's quite extensive. You can do a lot with it. There is a paid version as well. Fiddler is now owned by Telerik, and from its origin, it's a Windows-based application. They claim to work on Mac now as well. Actually, before this talk, I tried that, and it didn't go that well. It didn't go at all, actually. So yeah, they're trying to run it through Mono, and I tried to run it, but I didn't get it to work. There's also Wireshark. You might know that, but it's a bit more advanced, and you will actually see all the TCP/IP, a lot of things going on that I don't get. So yeah, if you're into pain and you like to see a lot of things seem like a hacker, text scrolling over your screen, then this is the one for you. And there's a little tool that I like to use. It's very basic, and it actually only does the HTTP calls, so that's the restriction right there. And that's called HTTP Scoop, which yeah, very basically has the same options as a Charles or whatever. So let's quickly look into that. You see here all the requests that are going through my machine right here, and little spoiler alert, if I go to my server application that is running on Azure, then you should see it showing up here, and we should see can inspect like, hey, what is the HTTP response, what headers were sent, response text, that kind of stuff. So very basically you can just see what was sent and how long it took, that kind of stuff. And of course, then there's the most easiest option, just switch on your airplane mode and see what happens. Of course, that's not entirely true. Then you don't have any connection at all. But when I just started working with developing apps and that kind of stuff, I didn't really think about all of this. I mean, I just worked out the app and I was happy that it was working as it was. And I just, yeah, I mean, I just had this scenario of always being connected, and the API was always reachable, until one day I thought like, hey, let's see what's going on whenever I switch on airplane mode and see what happens. Well, what happens if you don't take that into account, then your app probably crashes as soon as no requests come back and you don't have any exception handlers around it. Then you will just get an unhandled exception, and iOS and Android will just kill your app. So that was actually the case. So, but this is a very good first test scenario to just switch on airplane mode, go into your app and see what happens, and then you can work from there, like where can we improve. So it's time to have a look at some code. All the code can be found here. As I said, my Twitter handle is also my GitHub handle and basically everything. And because of the new Avengers movie coming out lately, I just thought, hey, maybe it would be nice to build a sample app around that. And so I did. It's a very basic app, which just lists a couple of members of the Avengers group. You can access some basic information about them, see in which comics they appear. Well, actually, that's some dummy data because I was done creating an extensive test set, and I just put in some random things there. And it's all built in Xamarin Forms with an ASP.NET Core backend, which is hosted on Azure. On the repository, all the code is included. There's an API, there's a client, and there's some information here, the resources, you will also see them later. There's also the hosted version, which is referenced here. So if you want to check it out, then you're free to use that one as well. It's on the free Azure tier, so go nuts. And if we just look at the backend, that's going to be the same for all versions that I'm showing you here. Then it's a very simple ASP.NET Core, what am I doing? Application with just two controllers, the superhero controller, which will allow us to get the superheroes from the backend. It just gets all of them or just one with some extra details. And one controller that gives us the comics that are associated to that superhero that we selected. Big enough. And here I build in some a little quirk that whenever some random number and the ID of the superhero is 2, then we randomly get back a internal server error, so that sometimes we have an error that we can see what happens, and we need to fix that. But other than that, you will just get a list of the comics. Data, I've created some fake little database. Actually, when I was preparing this talk, Marvel has this great API with all the data of all the universe they have in there. So if that's your thing, then go check it out. I extracted some basic data from it and put it into my own fake database thing. So here are some IDs, names, and basic information. And by the time I had this done, then I thought, hey, I don't want to do this. So here's the comics, which is just issue 1 to 42, etc. Is there anything else? Yeah, this is for later. I'm not sure. Maybe we can have the time to handle it all. I also took a piece of middleware. So I assume you have worked with ASP.NET Core sometime, and then the middleware, you have this request response pipeline, and you can write your own middleware. So whenever a request or response goes in there, you can hook into it and do some stuff with it yourself. So what I did was writing a e-tag middleware. I'll tell you more on that in a little bit. But basically what this does is implement a way of caching requests. I'll get to that in a little bit, and maybe then, yeah, it makes more sense to go into this. Then here's the client application, which is a basic Xamarin Forms application. So we have our Android and iOS projects, and also the core one with our shared data. And well, yeah, I'm not going to do anything with the Android or iOS specifically. It's all going to be in the shared part. It's all .NET Solutions. And here, well, I've got a couple of models. If I was being a super good developer, then these would have been shared between the backend and this app as well. But I was lazy enough to just copy them, and they are just wrappers around the data, so nothing fancy is going on here. Then I have a page, which just has a simple list view in this case, which will show an image cell with the name and the image of our superhero. And we can go to the details, which lists some details in labels and that kind of stuff. I'm not a very good UI designer, so yeah, this is it. And for the comics, there is another list view, yay, which will show the comics in there. But that's, of course, not really what it's about. This is where most of the magic will happen in our backend service. So here we have the API-based URL, as we've just seen. It just spits out some JSON objects. And yeah, we just create an HTTP client. You probably know this very well if you've worked with these kind of stuff. And, well, we just use this HTTP client to get our superhero and then check if our result code is a successful one, so it's a 200. And then we deserialize our objects right here. And also for the comics, we just take the ID and take the comics from here and do the same thing. So what you're already seeing here is that this code looks very similar. So that's something we would want to avoid, of course. I'll get to that in a little bit. That is the basic version of our app. Oh, maybe it's nice to show it in a running state. Let's see if I can get this down a little bit. So here we go. Here's a list of our, what kind of version is this actually? Doesn't really matter. A list of our superheroes that are probably in the movie as well. I didn't see it yet, so no spoilers, please. And when you click through it, you'll get his real name, some trivial data about it, and you can go to appeared in comics. Well, you will see this list coming in here. And if we look at the HTTP scoop output, then I would have expected to also see. No, this is probably some more advanced version as well. So normally you would have seen. Let's check out Android. Of course, our list of superheroes coming in as well. Here we go. So here you see HTTP 200, everything went okay. Headers and a response text. Well, here's just our fake database in a JSON format that is going over the network. And it's probably not going to be a amount that we, that's going to amaze you. It's going to be 8 kilobytes. But you can imagine if we're talking about a full-scale enterprise application, it could be much, much more. And if you do a lot of requests and responses, then this is going to be, a much larger number. And of course, if we go into one here, you'll see another, request and response going back and forth. So from this basic version, let's see what we can improve from that one. Some quick wins. There's one library, FF image loading, which allows you to cache the images. And actually, while I was preparing this talk again, with this basic version, with the basic list view, I expected to see the images being loaded like every time. And they didn't. And then I started digging, like, why not? What's going on here? Maybe it's not showing up in my tooling or what's happening. And actually, Xamarin Forms is even better than I had expected. They have implemented some caching by default. So don't use this. No, I'm kidding. There's some basic caching mechanism in Xamarin Forms, and by default, it's not just the list view; it's in the image source itself. And I think the default setting is for 1 day, and you have some control over it. But yeah, this one gives you even more control. And it also gives you control over where the caching is happening. So in memory is, of course, only for that application lifespan. Whenever you shut down your application, then it's gone. But you can also do it on disk, and then you can say, okay, do it for X amount of days, and then it will just cache your images that long. What it also has is deduplication of similar downloads and requests. So if it sees that you're requesting one image, maybe you have some placeholder for people that don't have an avatar, and instead of including it locally in your project, you're getting it from a remote source, then it will see like, hey, you're trying to get this 100 times over. Let's just get it once and show it only 100 times. And it also helps you with retrying image downloads. So for whatever reason, your download of the image fails because you are going with your Tesla into space, I don't know, just some random scenario, then it will try to re-download the image for a couple of times. Of course, that's all configurable. And it has some more awesome features that have nothing to do with networking, but while we're talking about this, it has some transformation, so you can make a circular image, or you can do it in black and white, or that kind of stuff. It has support for SVGs, WebP, or GIF or GIF. I'm not trying to make any enemies here. And it also helps you with loading and error placeholders. So whenever the image is loading, you can show some local image, or whenever the image can be loaded, you can show an image which indicates that there was an error, or show some general image, or that kind of stuff. This is actually a plugin that you need to install in your core project as well as the platform projects. So don't forget to write some little init line to keep your DLLs included and get everything up and running. Then there's the connectivity plugin by James Montemagno, which allows you to check the connection status. And it also gives you some information about the connection type, bandwidth, that kind of stuff. So whether you're on a metered connection or on Wi-Fi or that kind of things. And it also has some methods that are really nice to ping a remote server to see if it's reachable or not. So that way you can start detecting whether it's the local device or maybe the backend. And it also, in addition to that, it has some events to catch the changes in the state. So whenever you lose an internet connection, then you can, I don't know, pop up a message to the user like, hey, it seems you've lost connection. Some things might not work as expected. Also, I think at Build, they've announced this. James Montemagno has created a lot of plugins that you might know. And they've all bundled it into, I think, what they call Xamarin.essentials, also known as Caboodle as a work name. But the functionality of this will be the same. And then there's Refit, which will be the biggest quick win, I think, in this version. And that allows us to deduplicate all the code we need to do for the REST calls. So as you've just seen, the HTTP client, the calls we need to do for that gives us a lot of duplicate code, because we basically do the same thing but just for a different URL. We retrieve a string which contains our JSON and then deserialize it to the right object. And with this, you can just implement the contract with our REST backend API as an interface, and with some attributes we can configure where to get the data from, and we do not need to write all these duplicate code for the HTTP client and that stuff ourselves. We'll see how that works in a little bit. The calls will then be generated at compile time, and it's not just available for Xamarin, so it's basically available for all the .NET platforms you might be using. What I didn't mention just now is all these different versions are here up on GitHub as well. So of course, if you're on the master branch, this will contain all the latest code, but I've divided them up in a few releases here as well. So V1.0 is the basic app and backend, as I've just shown you. And here the V2.0 will contain our quick wins, so the FF image loading, connectivity, and refit. And I'm going to just skip forward in time here a little bit and just go to our v2 code, and then VS for Mac should pick that up nicely. Okay, so as you can see, the backend service already has some less code than just now. Basically, what we are doing is not create an HTTP client ourselves, but we create an instance of the iBackend service that I will show you in a second. And then we can just say on the interface like, hey, get superheroes, or hey, get comics for superhero. And that's all we need to do from now on. So no more instantiating of the HTTP client, specifying the URL that it had to get from, deserializing JSON, no more of that stuff. If we then look at the interface, then this is it. This is all we have to do. We specify the HTTP verb, so we also have one for post if we want to post some data, or even the, what do we have, patch, and that kind of put, everything is in here. And then we just have to specify the relative endpoint on our REST backend, and of course what type we expect from there. And it will automatically generate these calls with an HTTP client for us. I think it's important to note that you do not need to forget this slash in front. I'm not sure why it's so strict, but else you will get a runtime exception specifying like, hey, you forgot the slash in front. So I figured then if you give me this exception, then why don't you just try it with the slash in front yourself? But I don't know. Thank you for creating the library anyway. It's just maybe I can contribute this. I don't know. And of course, there's some other more advanced stuff that you can do here. I didn't implement any of this, but you can also, of course, do something with headers. So you have the header attribute to specify the content type, or well, any header that you like. Also some dynamic headers, and you can do stuff with authentication and get the token from somewhere. So there's a lot of stuff that you can do in here, and it will at compile time again generate all the calls for you. If you don't like to use HTTP client but use something else, you're still able to do that by just here supplying your own client for that. So if you have some specific needs for a different client, then you can still work with that as well. But this helps you a lot with deduplicating your code to get all your data from the backend. So the other stuff that we did wasn't as exciting as this was, but the FF image loading, basically drop-in compatible with the normal image, so it uses the same property names, source, that kind of stuff. But here you can see we can also specify the cache type. So we can set it to disk, a cache duration, in this case 90 days. And it also does some nice stuff for our memory restrictions. We can say, hey, downsample it to the view size, and then it will, if you get the nice cat image, which is 32 megabytes, it will downsize it for you to whatever size you are showing it on screen, and that way reduce the memory usage from within your app. And what did I do more? The connectivity. I think it's in the... Come on. The cross connectivity plugin. It's just you drop it in. It's a singleton, and you can just call upon that and say, hey, am I connected or not? And of course you can do whatever you want with that. And this also has some other nice stuff about the bandwidth, connection types, and events for whether something has changed or not. So this has all the stuff you need to get some basic information about your connection at this moment and anticipate on whatever is going on there. So now we already have a version which we can inform the user at least about what our connection status is, and limit some memory usage. But of course there's more we can do. So in version 3.0, we're going to add a library that is called Akavache, or I'm not sure how you say it, which allows us to very easily cache data on our application. If you've stored some data on a mobile application before, you probably know the SQLite library, and that's basically a layer on top of this. So if we wanted to do it without this library, then this is basically the procedure to do so. We're going to, whenever we request some data, we're going to check in the cache, check the network connectivity if we can get new data, then download the data, save the data to the cache, delete any stale data that might be in there, and then present it to the user. And yeah, this can be quite a thing to implement, of course. So then there is Akavache, and with this you can just basically specify, I'm getting this data, this is the key for it, and this is how long it has to be stored for. So that's very easy to use, very easy to incorporate in your apps that you might have right now. And why is this important? Well, again, it has to do with your user experience. If you start your app and there's no connection yet, or, well, again, the network call takes time, and you show the user an empty screen, that they're going to be like, hey, what's going on here? They might be a little confused. So that's why this is important. You can just show the user data immediately that comes from cache, that comes from disk, and it may be old, it doesn't really matter. And then in place, you're just updating the data and showing that to them, and they probably won't even notice that anything happened, but they'll be happy from the start and not be confused by an empty screen or whatever they might be seeing. So they perceive some sense of app performance that isn't really there. That's not true. But also, this is not just for Xamarin. You can use it on other platforms as well. Excuse me. So if we skip ahead in time again and go to our next version, reload from disk. Then we're going to see most of the changes in the backend service again. And now I've added a variable here. There's different places where you can get the cache, where you can store the cache, or you can store the data in your cache. Probably most of what you'll be using is the local machine or the user account. On local machine, you'll just store it somewhere in, I don't know, some temp cache folder. If you read the documentation for this plugin, of course, depending on the platform, it will save it somewhere else. But you will see that it gets cleaned up whenever the OS decides to. And the user account actually gets saved to, well, the user account, so the folder that's associated to the user on a mobile device. That's probably going to be just one folder, but it will also probably be synchronized to iCloud or Google Drive or that kind of stuff. So whenever your app gets reinstalled, then it will also get this cache back. Not always convenient, but in some use cases it might come in handy. In this case, I've stored it in the user account just because we can. And whatever you see happening here is that now we're returning an iObservable. So we're getting a lot of reactive stuff together with Akavache. And this is basically because what happens here is we're going to return from this cache the get and fetch latest. And this is our key that we are storing it in. So this will be the superheroes. See it as a superheroes table, and this is where all the list of the superheroes will be saved. And our second parameter will be our remote call. So here we see only this line was here before. And now this is used to get our remote data. And here is where we determine whether our cache is stale or not. So we get this offset, like, hey, when was this data last received? And from there we can decide, like, hey, is our offset now minus the offset that when we got the data that we have in our cache now. Is it more than 24 hours? Then our cache is stale and we need to get in the new data. And before that, we can use the connectivity plugin again. And if we're not even connected, then we're just going to return false because, yeah, we don't have the opportunity to get any new data. So we'll just show the cached data here as well. And the same for the comics, but for our little demo, I've set the cache to 5 seconds, so we can see that, yeah, it really works and it doesn't do a network call all the time. Also here, I've moved our remote call to a separate method. Didn't really make sense here. Normally you probably would, but here I know that a exception could show up, and in the other one it shouldn't. So if we would run this, that's why I earlier didn't see the network call for the superheroes, because this version was already installed and it had the superhero cache here already. And now whenever we get our data in the page model, you see the iObservable in action. So now we're saying like backend service get superheroes, and we subscribe to it. So whenever we get data, we will go through here, and this is what we will do with that data. And if the cache is invalidated, then you will come here twice. You will come here once with the data that is in your cache at that moment, and then, well, shortly after that, hopefully, then you will get the new data, and you can update it through here as well. And then, yeah, for iOS and Android, the way the UI updates, you really can't really tell that data is really updated.
So you'll see something no matter if you're online or offline.
Yeah. And, well, because I have to check for the cross connectivity, if I'm connected or not, you will just see the cached list and you'll think everything will be okay. You probably want to notify the user that something is going on, because else they will run into problems, or if they somehow know that this data is old, then yeah, they're going to wonder as well. But yeah, you'll still see data. So if we look at this, you'll see we're coming here once, and this is cached, so no network is going on here. And if I go here, then we get a big fat exception. That's nice. Not sure what's going on here. Let's try that again. This is our superhero list again. Should only get here once. Nope. On Android then. So what we should see happening here is that, well, once we get the list from the remote, because our cache is only like 5 seconds, and then if we refresh within 5 seconds, then nothing should happen. And after 5 seconds, we should get the list again. And also, so here, you can, of course, write your own logic to whatever invalidates the cache. So yeah, you can, most of the time it will probably be some time offset that you will determine. But there's all kind of things that you can do to decide if your cache is still or not. Not really sure what is going on here. Well, this seems to work on Android for some reason. So if I do it now, this was 5 seconds ago, so you see another call showing up, and now probably as well. So no, And if I do it within 5 seconds, then nothing happens, but I'll still be presented with the list. And whenever I go back and come back here, then you'll see a list at first, but since there's no actually new data, you don't see it refreshing. But normally you would see something going on, but you'll have the sense of something is updating in place, and you'll get new data without actually confusing the user with that. Okay, so there's one thing you need to know for this is that you have to set the application name, which will probably be the name for the database that is being used on the beneath the Akavache layer and the SQL database layer. There's some other things I ran into when I started using Akavache. It fails silently whenever you don't add the SQLite 3 package. It will just use the in-memory caching without you notifying, like, hey, I'm doing something you might not expect. So yeah, between each app restart, I was like, where did my cache go? But it didn't persist on disk. So yeah, that's why it wasn't there. Also, again, if you've worked on Xamarin projects before, you might know that some DLLs are linked, are optimized out by the linker because there's no reference in the platform projects, but only in the core projects. And then it will say, hey, this is not used in this project, so I'll take this DLL right out of there because it's only taking up disk space that you're not using. So there's a little file, I think it's also in the documentation, for the linker override, which basically just gives you some references to some arbitrary variables to let the compiler know that we actually do need these libraries in there. And then there's the thing of, I don't know, basically safely removing your USB drive, something kind of thing. For the blob cache, do a shutdown so we don't saving data, just shut down and have a corrupt database. So what you should do is a shutdown wait, but yeah, the way a mobile application, the way the lifecycle works, you can't always guarantee that this will run. So what I did do is basically in our app lifecycle here on the on sleep, put this line. But yeah, whenever a application is closed, I think forcefully from the multitask screen, it's not always guaranteed that it will go through this event. So another good workaround or solution for this actually would be to wrap it in some kind of repository pattern. So whenever cache is going in or out, that you just close the connection at that point. So your data integrity will be guaranteed at that point. There is one alternative to this. It's the Monkey Cache, also by James Montemagno. He creates all the awesome stuff. And it basically does the same thing you have here, but there's some more manual work that you have to do there. But you have a few different data stores there. You can save it on file in JSON files, I think, and you also have some other database options to use. And it also has support out of the box for the E tag that I hope we still have time for. But still, we have now implemented some caching, and the user will think that data is there instantly. But we didn't really take account for the fact that requests might fail. And that's why we have another library, which is called Polly. Again, not just for Xamarin, can be used for a lot of platforms as well. And what this does is basically allow you to define policies for whenever a network request fails, how to handle that. So the basic thing or what I used to do is just say to the user, hey, this request failed, you might want to try it again. But we as a developer probably better know how to deal with some error that might show up. So if it's 404, then you're not likely to recover from that, but it's 500, then you might be able to recover by that. And of course, there's lots of different scenarios based on the HTTP status code. So Polly can help you with this. There's a lot of text in here, don't read all of it, but these are some of the policies that are in there. So you can just specify like, hey, do this request, and whenever it fails, you can retry it, and you can configure this to do this like 3 times, 4 times, as many times as you like, and also have some interval between it, like, hey, do it in to the power of 2. So you each time between each retry, there will be some time to not just go at the server each second and see if it works now. There's also the timeout. So yeah, if you've been waiting 5 minutes for a request to finish, then it's probably not likely that it will ever finish at all. Don't set it to 5 minutes. That's not going to work. But yeah, so there you can specify some kind of timeout to just cancel the request there. There's also some failback, which is also nice. You can return whenever a request fails. You can say, hey, here's the fallback value for this. And just return some arbitrary object, or maybe some cached object, or that kind of stuff. So if we quickly switch to that. Which will also happen in the backend service. Then you see for the comics, because that is where I intentionally put the error. You now see that it's also wrapped in a policy. Of course, here's the risk of using duplicating all this code again. You can also define this policy once and then just only specify what needs to happen for executing the request. But here you can say, okay, I want to define a policy. And here you could specify like, hey, whenever this type of exception shows up, and I've also specified here that whenever the status code is not found, like I said, 404 is not likely to recover. So whenever that exception happens, then we just throw it at that point, because yeah, then it's just in error. But if it's anything other than that, we're going to wait and retry it for 3 times, and we're going to have that to a power of 2 for each attempt. So the first time it will wait 1 second, then, well, you know. And on retry, we can do something for each attempt. So here I'm just logging like, hey, this request fails. And so we know that something is going wrong. And this is then the code that we want to actually execute to get our data. So if we run this, it takes a little while. Android. Sorry, I'm an iOS fan. Okay, so here we go, going through the cache. And Captain Marvel was our culprit. So here we go in the log here. We see, hey, something went wrong, retrying, trying to fetch remote data, and the second time we got it. And all of this while we didn't have any errors or unhandled exceptions or that kind of stuff. We can also see it going on in the logs here. We first got our 500 error code, and then we got a 200, and we still have our data nicely here. So if I would repeat this, then yeah, we'll probably have the success right now, and also the caching within 5 seconds. So I'm not sure if I can reproduce this again. Here the 500, and then we get the 200, and everything is still okay. And this works for a lot of other things as well. This is just the retry mechanism, but you can have, like I said, you have some other stuff in here as well that will help you, yeah, make your app more resilient to this kind of failed requests. Running out of time here. So you have some conditional requests, which is the E tag I've been telling you about since the start. What this basically does is you specify some hash with your response the first time. It can be any hash you want, MD5, the SHA1, or whatever. As long as it's unique to whatever is contained in that response. And then whenever you have to save that tag, of course, yourself. And then whenever you do, you send that one with the next request. And at server side, they will be compared like, hey, this E tag, is this changed since the last time you got it? And if not, it's not going to send the full content again. So that way you are not sending the data that you already have over the line again to save bandwidth. There's a couple of things that you can use. You can also say if modified since and that kind of stuff. It's called HTTP conditional requests, which basically means that you can specify some data in these headers, and then at the server side you can determine what to do with the data or not. There's more things that you can do with it, but the most common scenario is caching. So let me quickly just go and show you that. It's not very complicated. Like I said, on the server side of things, I've wrote some middleware for it. So all the requests that are going in and out, I'm checking on the one side. I'm generating the E tag. So what you should see happening here is all the succeeded requests have a header which contain the E tag. So this is a hashed version of the contents that you will see in here. And then with each request, I now build into the app the E tag HTTP client handler. I cache this E tag that's coming from the response, from the response the first time. I put that in a cache as well. And then whenever I try to, with the key for the endpoint where I got it from, so I'm getting data from the /superheroes endpoint, and I'm getting an E tag from that. And then I save the /superheroes as a key with the E tag as a value. And then whenever I do a new request for that same endpoint, so the /superheroes, I include that E tag as well. Send that to the server, and whenever the server says like, hey, this E tag is the same as before, then it doesn't send me the data again to save bandwidth. Well, I guess you'll believe me, I'm over time already, so I'll just go ahead. So that's the things I have for you today. Write less code. I think that's always a good advice. Also refit. There's also a thing that I didn't show you is property change.fody, which is also a very good library to not write redundant code. It has to do with the iNotify property changed. And while developing for mobile applications, keep in mind the limitations that are still there, not just for the CPU and the memory, but also the networking and any cost that may be associated with that. Give the user the perception of speedy loading. So yeah, it doesn't have to be perfect and all, but just make it your priority that the user feels like everything is going smooth, and that they are not confused by empty screens or strange error messages or that kind of stuff. And the more optimizations possible with the E tag that I've just shown you. Here's the resources, some resources that are blog posts which which describe basically what I've done here. It's also in the GitHub repository that all the code is where all the code is in, and that's all I have for you today. Thank you. Enjoy the rest of the conference, and when walking out, please put some green papers in the box. And if there's any questions, you can come up. I have some stickers to decorate your laptop if you want to, and I'll be walking around here tomorrow as well. So if you have any questions or you want to chat about anything, then please find me. Thank you.